Well, hello guys, welcome back to Mr. G Physics. This is the channel that can help you with physical sciences at high school level. Today we're going to be doing more questions on frictional force, only one more, but this time we also have to calculate normal. It's quite important because normal do not have a formula, actually can be confusing. I'm Mr. G, and if you didn't subscribe for the channel, please don't forget to subscribe so you can get the notification on all videos I post on regular basis. This question says a 10 kg block rests on a horizontal floor. The coefficient of static friction is 0,40 and the coefficient of kinetic friction is 0,30. So let's start by writing this data here outside, and I'm going to write it on this side. Coefficient of static friction is 0,4, remember not unit. Coefficient of kinetic friction is 0,3. There we go. Determine the force of friction acting on the block, and they give you different scenarios whenever they have a applied force of those magnitudes. There is another data which is the mass. They are not giving you this time the normal force. They're giving you the mass. So how to get the normal force? We'll see. Now determine the frictional force. Whenever there is no force acting on the object is not moving or is not trying to move, is not attempting to move. Therefore, in the question 1.1, the frictional force is equal to 0. There is not friction there. That is question 1.1. That one is the scenario of the box on a floor. In this case, it's a floor, so you have this scenario, the block on the floor, and therefore the object is not moving. There is not friction. We spoke about this one before. Let's move this one here. It's part of this question, and this one is going to be question 1.1. Now 1.2, the question says determine the frictional force if the applying force is 20 Newton. Guys, we cannot determine the frictional force. We don't know if the object is going to move. Therefore, the first thing we have to do always is to calculate the maximum static frictional force. So yes, we need to calculate the maximum static frictional force before anything else, because that one is the one that is going to tell us if the block is going to move or is not going to move. So we are going to calculate that one. So we're coming back here. Maximum static frictional force is equal to static coefficient of friction multiplied by normal, and here is where the problems begin. Simply because we do not have a normal force, we don't know this one. So we're going to learn now how to calculate normal force. So what we're going to do? We're going to do a force diagram because we have to move all the way back to vectors. So what we are going to do is we are going to do a drawing of more or less the situation and draw the forces that are acting on that block. First of all, we know that there is an applied force of 20 Newton. Applied force of 20 Newton. This is not important right now, but let's do it. So this one is a force equal to 20 Newton. I'm not going to give a name. We'll learn about that one later on. There is frictional force for sure because the object is trying to move. Now, I don't know how strong, how big is this friction. It's not important. I only know that there is friction for sure. So I'm going to write frictional force, and I don't know the value. There is a weight on that object. There is weight on that object, and you know what? I'm going to erase that number that we don't need it, and it may get us confused. There we go. So we have also weight pointing down. Remember, it's towards the center of the earth, but we are going to write down. And there is normal pointing up on the object. And I'm going to draw normal with another color. This is normal force. Those are all the forces acting on that block. Now, we are looking for normal. Normal is in the vertical direction. I'm going to call this one vertical. You can write y-axis. Right? So, in other words, we are going to focus on what is on the vertical axis. Alright? Now, we know for sure that the object is not moving in the vertical direction. We don't know if it's moving horizontally, but definitely it's not moving up and down. Okay, that is important. Therefore, the forces are at equilibrium. The forces are at equilibrium. This one was learned in vectors. What means that the forces are at equilibrium? Everything on top is equal to everything at the bottom. Okay? In other words, we can say here that the normal force is equal to weight, because that is everything you have on top and that is everything you have at the bottom. Guys, this is not a formula. This is the solution for this specific question. It means it can change. So don't learn it like by heart, because it's not like that. It can change. For this situation, it's very simple. It is like that. Normal force is therefore equal to no a formula, only for this situation, and that is what we are going to substitute in the only for this situation. I'm going to go back. Why is that so? In the y-axis, those are the only two forces acting. We're going to learn about this one eventually. Those are the only two forces acting on the y-axis. They are at equilibrium because the object is not moving. Let's write here. Object not moving means there is equilibrium in the y-axis. Equilibrium in y-axis or vertical. Okay, that is the thing. Everything top is equal to everything at the bottom. I hope you get that one now. Then the problem is almost solved. Maximum static frictional force, therefore, for this question will be equal to static coefficient of friction multiplied by mass multiplied by acceleration due to gravity is coming from them. Okay, and then guys is the substitution. We have the value, so let's really substitute real fast. It's maximum static frictional force is equal to 0.4. The mass is 10 and acceleration due to gravity is 9.8. There we go. So when you do this substitution, and we get that is 39.2 Newton. Now, not the following. This one is obvious in the opposite direction. Okay? Now, remember, this is not the question. The question was, what is the frictional force when the object is, or when the applied force is 20 Newton? So, now the scenario is the same we have here, exactly the same. The force is 20 Newton. So, what is going to be the frictional force? Okay, what is going to be the frictional force? Well, the maximum static frictional force, we're going to write it here. This one is out now for question 1.2. The maximum static frictional force is greater than the applied force. Therefore, the frictional force is going to be equal to the applied force, which is equal to what we say 20 Newton. We need 39.2 to move the object. So this is there we go. It is 20 Newton in the opposite direction because the maximum static frictional force is greater than the applied force. Quite simple. What happened to question 1.3? Same story. 1.3. The maximum static frictional force is still bigger than the applied force. Note the following. In this case, they say they applied 39 and we got 39.2. It's not exactly the same. Therefore, the frictional force is equal to the applied force, which is equal to 39 Newton in the opposite direction. And now, the final one. What happens if you apply a force of 41? Well, 41 is greater than the maximum static frictional force. It means the object will move. And then you have to calculate the kinetic frictional force. So we come in here, 1.4. Now we have to calculate the kinetic frictional force. Why? Because the object is moving. So it's kinetic coefficient of friction multiplied by normal. Normal is exactly the same, it doesn't change. So in other words, in this situation, normal, remember, got mg. Remember, it's not a formula. So this one is the kinetic coefficient of friction multiplied by mass multiplied by acceleration due to gravity. Okay, so the kinetic frictional force is equal to 0, I think it was 0,3. There we go, 0,3 multiplied by the mass, which is 10 multiplied by 9,8, and we get 29,4 Newton in the opposite direction. And guys, this is all for today. We learned how to calculate kinetic frictional force, static frictional force, but we also learn how to calculate the normal force when we have a situation of an object in a horizontal plane with a force acting parallel to the surface. If this is the situation, in other words, if this is the situation, normal force is always going to be equal to mv. But as soon as you change the direction of the applied force, that will change, guys. If the plane is not horizontal and is on incline, that will change, okay? So it changed a few times. But thank you for watching. I hope it helped. If it helped, thumb up. Subscribe for the channel. I'll see you next time. Mr. G here.